Hi everyone, welcome to the GenAI awareness course. This is the first introduction session, and in this session we're going to cover the basics of generative AI, and that just starts with understanding some of the fundamentals. Once we understand some of the fundamentals, we're going to be able to have a broader conversation around these generative AI tools. So the course is being run by Atlantic Technological University, and the course has been developed and supported in partnership with Data2Sustain, eData, Regional Skills, and Peace Plus. So we've got a load of supporting partners that have helped us with this course, and we'll be running the course over the next 4 sessions or so. So first of all, we're going to look at what is generative AI. So the textbook definition is given here, and it tells us that generative AI refers to artificial intelligence systems that can create new content, whether it is text, images, code, audio, video, whatever that new content may be. And it does this based on patterns learned from training data. So I know a lot of that might sound alien to you at the moment, but we're going to work through, and hopefully by the end of this session you should know what generative AI entails. So if we look at traditional AI, traditionally we could use traditional AI models like machine learning models and things like that to analyze data. And some of these models were very, very good at classifying information. So, for example, some examples that we've heard of, maybe, or that you might be familiar with, is healthcare diagnoses. So, for example, there might be a lot of information or data that we have on patients, and these machine learning models are very good at figuring out patterns. So they became very good at being able to classify somebody, whether they, let's say we're trying to diagnose cancer, for example, whether they had cancer or not. So they're very, very good at classifying information. Also, they became quite good at making predictions. And again, this is from analysing existing data to see patterns that we mightn't have seen before. So these systems were very, very good at that. So some examples of traditional AI would be things like, the spam filter in your email. This is using, some of these data science techniques that would have been seen as traditional AI. So they are used in spam filters. Recommendation systems are probably the most common one that most people are aware of, and these are things like when you're shopping on Amazon, they recommend an item based on what you're buying at the moment, or on Spotify they might recommend a certain song based on the music that you're listening to at the moment. So again, this is a very good example of how we can analyze existing data, classify that information, and then make predictions. So if I think about a recommender system in Spotify, it would have my existing listening history, and then it would kind of classify me. So it would say, let's say if I'm always listening to rock music, then it kind of classifies me as that type of listener. And then once it knows that I'm in that kind of category of listener, then it can make predictions based on both my class and my previous playlist or listening history. So this is how these recommender systems work. You can think of them as the traditional AI approach. And again, this is just learning patterns from this existing data. Now, generative AI is a new paradigm shift that is quite recent, within the last couple of years. Generative AI is focused on creating new content. So it will be trained like our traditional AI. Okay, so it looks at existing data, but then it is generating something brand new. The outputs that it generates are typically original, and depending on the tool that you're using, they will give you the intellectual property is yours. They will respond to prompts, so that's essentially how the tool that we're going to use to get these generative AI tools to work in a way that we want. And some of these new tools, we're going to look at this in later sessions, but some of the tools that you may be familiar with are things like ChatGPT, DALL-E, and Claude. So again, this will be in a kind of a future session where we'll go into a lot more detail in some of these different generative AI tools. So generative AI is, we have this artificial intelligence as a field, and then we have traditional AI as a subset of that, and then generative AI is a subset of traditional AI. So you can think of it as building on top of the traditional AI. So if we look at how is generative AI starting to become part of our daily life, Well, I'm sure a lot of you are probably familiar with ChatGPT. Most people, when they hear AI, they automatically think of ChatGPT, and they, kind of don't really move beyond that tool. So ChatGPT is good for things like writing emails, summarizing reports, or even writing reports, answering questions on a complex data set, and also really good for brainstorming ideas. So if you're starting, with a blank page and you're trying to come up with some kind of idea, it's good. It's a good tool to kind of test your ideas out on. DALL-E then is really more of for the artist. So this can convert text to images. So, and again, this is original content. So I could just give, a text description of an image that I want to see, and this tool will create that image. And this can be, used for loads of different things. So if, let's say, for example, I just wanted to change the layout of my living room, then I could put in a prompt into DALL-E and give it the picture of my living room, and then say to it, could you rearrange this in such a way, and then it would do that. So you can use it for different things like design concepts, but yeah, the use cases are endless with these things. GitHub Copilot is one that is becoming more and more useful and more widespread in terms of writing and debugging code. So it's also really good at writing documentation, and we can see that a lot of people are starting to have GitHub Copilot within their workflows, especially when it comes to developing code and complex code. Then we have Google's Gemini. This is Gemini's really good for long, complex reasoning, and we're going to look at why is that, why is the Gemini tool good for that specifically. It can be used for things like research. It could be a research assistant. So if you were doing, for example, some market research, then Gemini would be a really good one. And obviously, because it is a Google product, it's integrated with a lot of Google products like Gmail, Google Drive, all of that. So you kind of the benefits of using Gemini is you get the whole Google ecosystem along with that. Claude is I suppose this is Anthropic that have created Claude, and this is just another more specific generative AI tool. So it is really good at analyzing documents, quite large documents, and again, for researching and for higher quality writing. So we'll typically see a lot of Claude being used quite a bit within the legal profession, because they have to analyze a lot of large documents. They have to make sure that their writing is of high quality, and things like that. So we can see that being used more and more. And finally, music generators. So there are tools out there. OpenAI have one, for example, that will create original music and soundtracks, essentially just, again, from text prompts. So these things are creating, if we look at the data type that we are using, this is going from text to text. This is from text to image. This is from text to computer code. Again, text to text. Gemini and Claude are actually multimodal now, so that means that they can understand text, pictures, audio, video, so they can understand quite a lot of different data types. And then this is just text to audio as well. So loads of different. This is only just scratching the surface. Like I say, we're going to get into the actual tools themselves, looking at comparing the tools and seeing what tools are right for the right job. We'll look at that in a later session. But this is just how a lot of people are using generative AI already within their daily lives. So this generative AI revolution seems to kind of just been thrust upon us, quite suddenly, but actually this has been worked on for quite a long time. So artificial intelligence research has existed since the early 1950s, but it hasn't really been until the last decade or so that we've had these recent breakthroughs that have made these tools actually quite useful and accessible to pretty much everyone. So they're becoming more and more ubiquitous, and we're probably only going to see them becoming more ubiquitous and more ingrained within our daily lives. So how did this happen? How did we go from this thing being a kind of a nice thing to have and something that was researched, even through the 1970s and 1980s? There was a period of time called the AI winter, and essentially is where the whole world had given up on researching artificial intelligence, apart from a small group of researchers. So what has kind of changed? How are people now coming back to this again and are interested again? Well, the first thing is the scale. So we might have had, let's say back in the 1980s, we might have had the actual theoretical knowledge, so the actual tools to create these things. But just the nature of artificial intelligence, it has to be trained on existing data. So we didn't back in the 1980s have that much data around in terms, of digital data that we could feed into these computers or these machines. But nowadays, we've got 40 years or so of internet data, and we're at the point now where each person is generating gigabytes of data per day, from their smart devices, from just their digital footprint. So the scale of data has definitely changed, and that has helped. Computing power is another big one. We didn't have the compute power back in the 1970s, 1980s, even the 1990s to train these models so quickly and so efficiently. So we weren't really able to, even if we did have the data back then, we wouldn't have had the compute power. It probably would have took us, the lifetime of the universe to train one of these models. So that's not useful. That's not feasible at all. That's not going to be something that we can get any use out of. So as we know, with Moore's law, computing power has essentially every 2 years or so, it has doubled in capacity and halved in price. So it's got bigger and cheaper at the same time, and we've had again another 40 years of this of Moore's law playing out. So our compute power is really quite powerful today. The architecture changed. So the way that we were trying to build these language models was quite different before a thing known as transformers came along. So transformers really, I'm not going to go into too much detail about the architecture, but really what it enabled was the understanding of context, and that small little key element absolutely changed the game. So now we could have these machine learning models that actually understood what we were talking about. They understood the context of what we were trying to ask of the model. Accessibility as well, user-friendly interfaces have changed. So if you think about ChatGPT, they basically put a WhatsApp interface onto one of these large language models, one of these generative AI models. So they made it really easy to talk to this thing, because if you didn't have that ease of access, then most people wouldn't use it. So they made it quite easy to access and easy to use. And then, of course, as we know, as you probably have been reading in the news lately, billions and billions have been invested in AI research and development, and this investment is only increasing with time. So Google, whenever they bought DeepMind, which was an AI company, very soon after that, then they had their model that beat the champion human Go player, and that was seen as a massive shift. So that was seen as, hold on, these models are now becoming a lot more smarter than we had imagined. So this investment has been going over decades and decades, and it's only now that we're starting to see kind of the return on this investment. So like I say, the key innovation in all of this, if you pull any one of these out, then we're not going to be able to create these tools. So we kind of needed the stars to align. We needed all of these things to happen, but the transformer architecture is the key one. We might have had the data, we might have had the compute power, we might have had the user-friendly interface, we already had the billions, but if we didn't have the transformer architecture, then again, that was the kind of pivot point in which these things could start to understand the context, and therefore they started to generate text that was actually useful to us.